Hi, my name is Stephanie Cole. I'm a graduate student in the Department of Computing and Software Engineering here at McMaster, and today I'm going to be presenting a paper called Grand Challenges in Model-Driven Engineering, an analysis of the state of the research. And this is authored by Antonio Bucchiarone, Jordi Cabot, Richard F. Paige, and Alfonso Pierantonio. It was published just last year in January of 2020, and since that time it's been as of the time of this video, which is April 2021, it's been cited 34 times. So an agenda of what we're going to be going over today, I'm going to start with a summary of the paper, and the format of the summary roughly follows the format in which the items are presented in the paper. So we'll start off with a history of model-driven engineering, and this is delineated by pre and post 2007 in the paper, so that's the way I'll present this summary as well. And then we'll talk about what are these grand challenges in model-driven engineering, and that's split up into social and community challenges and technical challenges. Then I'll give a critique of my thoughts of this paper, and we'll finish it off with a summary of everything covered. So starting off with that brief history of model-driven engineering, we really see the origin in 1994 when the Unified Modeling Language, or UML, was developed. And after that time, the late 1990s to about 2007, this period is really characterized by a lot of modeling language issues. So there were substantial changes to UML semantics, infrastructure, and superstructure, and a lot of the research at this time had to deal with the precise semantics of modeling languages, meta-modeling, and model management. And so a quote I grabbed from this paper says, "In essence, this period laid the groundwork for more recent research, providing the foundations needed for more advanced research on modeling tools and model management." And so after that period of really laying the groundwork, there are 7 different categories of which research kind of fell into. So the first of which was language engineering. So this is kind of similar to what was being worked on before. So it's principles, practices, and patterns for specifying abstract and concrete syntax and semantics. Then we have language workbenches, so tools for defining and composing domain-specific languages, and their IDEs. We have model management, so these are processes and tasks for manipulating and analyzing models. And then, of course, we have the model analysis itself. So what techniques are we using to analyze the models? We have models at runtime, so after deployment, using these models to manage and understand systems while they're running. We have different modeling repositories that have been created, Remod, the Atlantic Zoo, MDE Forge, and others. And then last, we have scalability across different dimensions. And this is a point that we'll see come up a lot in the challenges going forward, is being able to scale. And this point says support for working with very large models. So we've proven that model-driven engineering has worked very well in small scales with small models, but scaling it up to very, very large and complex models is definitely a huge challenge. And so speaking of challenges going forward, like I said, that's delineated by technical challenges and social and community challenges. So on the technical side of things, we have 3 different pillars. The first of which is foundation challenges. So this is conceptual and theoretical aspects of model-driven engineering. And a lot in this section of the paper we see hoping to integrate with current widespread methodologies. And one that they mention a couple times is agile and lean development, which are obviously very, very widespread in modern engineering, especially software engineering. So how do we make sure that model-driven engineering integrates very well with agile? Then we have domain challenges, so application domains of systems developed using model-driven engineering. And so this lends very well to domains that have safety, security, or privacy concerns. So areas like healthcare, aerospace, nuclear, automotive, that type of thing. And then the last kind of pillar of challenges we have here is tool and implementation challenges. So developing tools that will increase adoption. So things like visualization frameworks or more intelligent and self-aware tools. So making use of the increase in cognification that we've seen to have tools that are more autonomous. And for the social and community challenges, this is broken up into social versus community, though the delineation isn't very large here. They're quite similar. So we have for social challenges increasing non-technical adoption. So making sure that non-technical peoples can build the tools that they need in their respective domains using model-driven engineering. So this would be an incredibly powerful use of MDE moving forward. So some of the ways that we could achieve that, as outlined in this paper, are example-based modeling, affordance to work at the instance level, so something kind of like a Excel type program where you can work directly with instances instead of working with the larger kind of models. Then we have domain-specific MDE, so having model-driven engineering for healthcare versus MDE for automotive versus MDE for banking, that type of thing. And then for community challenges, we have, again, increasing adoption of MDE, but on a more kind of wide scale. So how do we actually get that adoption? And they talk about MDE evangelism, so people who are already familiar with model-driven engineering to evangelize about it and get other supporters and adopters on board. Large model repositories with quality assurance. So instead of just having a large repository of models that people can use as examples, making sure that there is some sort of quality assurance criterion attached to that, so we make sure that people who are just learning about model-driven engineering aren't using bad models. And lastly, education for both MDE adopters and MDE builders. How do we make sure that we're properly educating the next generation? And so in terms of impact of model-driven engineering, it's allowed us to leverage abstraction and automation in almost every area of software and systems development and analysis. So that leveraging abstraction, that allows us to communicate more effectively about these very complex systems and allows us to abstract away these kind of nitty-gritty details so we're able to communicate more effectively about them. And then using model-driven engineering to leverage that automation to make sure that we're saving time and eliminating some errors in the software development process. So some of the areas that we've seen adoption of MDE are, as it outlines in the paper, railway systems, automotive, business process engineering, embedded systems, and many more. And they also note that models are key to success in modern software engineering processes. So overall, I thought this paper was well formatted, it was organized, and it was a really engaging paper. There wasn't a lot of jargon or redundant wording. It was pretty clear and to the point, which I really, really enjoyed reading. I thought it was a great overview of the history and future challenges. Some of the critiques I have, though, is there wasn't too much emphasis on the progress that has already been made in respect to these following challenges. And I was feeling like I was missing like a big picture view of why model-driven engineering opposed to some of the other methodologies and processes that we have out there. What is so special about MDE and why focus attention on that as opposed to some of the others? I know there's good reason for it, but I just didn't see that outlined in this paper. And then my next critique was that the categorizations felt somewhat arbitrary, and I noted that when I was chatting about the difference between social and community challenges, they felt very similar to me, and there was maybe a slight distinction that one is more towards a niche community, but it still felt kind of difficult to grasp. So that was my last critique there. So in summary, there has been a shift in the trajectory of model-driven engineering development away from establishing this strong foundation, which has been proven and has been proven to be effective. And now we're moving towards more widespread adoption of these processes and tools that are very effective. So there's a wide array of technical and social community challenges, though, like I said, they all seem to focus around more adoption. And I thought it was a great framework for which challenges to address, but it also provides context for future research projects to assess progress. So here's the paper that I was talking about, and the icons were gotten from flaticon.com if you're interested in that. But otherwise, thanks so much for tuning into my presentation. I appreciate you taking the time to listen, and please let me know if you have any feedback or questions.